Hello everyone, welcome back to our CCNA learning series. I'm Sparsh and today we lay a professional foundation for every lab that follows. By the end of this video, you'll be able to navigate the CLI and perform a secure and professional baseline configuration for Cisco devices. Confidently move between user exec, privileged exec, and configuration modes. Perform a secure day 0 setup on a Cisco device, configuring hostname, admin user, enable secret, banners, console security, SSH-only remote access, and VTY restrictions. And also verify and save your configuration properly for future labs. In this lab topology, we have a PC connected directly to the router R1 via a console cable. Initially, the PC is used to access R1's console port for configuration. Once R1 is set up with a management IP address on its gigabit Ethernet 0/0 interface, the PC can connect to R1 over the LAN using SSH for remote management. The switch is present in the diagram but will not be used or modified in this lab. The main workflow is use the console connection for initial setup, then verify remote access via SSH from PC to the router. Before we dive into device access, let's quickly introduce Cisco IOS, the software that powers most Cisco routers and switches. Think of IOS as the brain of the device. It handles all networking functions, security, and management. Whenever you connect a Cisco device by console, telnet, or SSH, you are interacting with Cisco IOS through its command line interface. How to access a Cisco device? There are several ways to access and manage a Cisco device. Console access. This is the most direct method. You use a console cable to connect your PC directly to the device's console port. This is essential for initial setup, password recovery, or troubleshooting when network access isn't available. You don't need any network configuration, just plug in and open a terminal emulator like PuTTY or TerraTerm to access the CLI. Console access is always available, even if the device is misconfigured or network is down. Then the aux port. Some older Cisco devices have an auxiliary port for modem access. This is rarely used today, but it's good to know for legacy equipment. Then comes telnet and SSH. They both are methods to access your device remotely over the network. Telnet is easy to set up, but it's not secure. Your username and password are sent in plain text. Telnet is useful for quick lab setups, but never use it in production environments. You must first configure an IP address and enable VTY lines on the device before you can use telnet. SSH, on the other hand, is the secure alternative to telnet. It encrypts all traffic, including your credentials and commands. SSH is the industry standard for remote management. You'll need to generate crypto keys and set up a local username and password before enabling SSH. Always use SSH for real networks. Now let's talk about what is CLI. CLI stands for Command Line Interface. It's the text-based environment where you type commands to configure and manage Cisco devices. The CLI is the heart of Cisco networking. Almost every feature, setting, and troubleshooting step happens here. When you connect via console, telnet, or SSH, you are greeted by a prompt. In this case, it is router followed by an angular bracket. You type commands directly. No mouse, no menus. This gives you full control and speed. Cisco commands follow a strict structure. Command followed by options, which are then followed by parameters. For example, if I type show clock, it displays the current time configured in the device. You don't need to type the full command, just enough letters to make it unique. For example, if you type sh-clo, it will still run the show clock and display the current time. We can use question mark at any point to get help. For example, type show space question mark to see all available options for the show command. I can also use tab to autocomplete commands. This saves time and helps avoid typos. Many commands have submodes and options. Don't be afraid to experiment and use help. Let's jump to the packet tracer and set up our devices. I will add the devices step by step. At the bottom left of your screen, you will find the device palette. Select the router 2911 and drop it to your workspace. Let's add a switch. Click on the switches, select the switch 2960 and add it to the left of our router. We'll repeat the same for an end device. In this case, we'll be choosing the PC. I'll drag and drop it to the left of our switch. Now let's connect them physically. At the bottom left, click on this icon which says connections. Click on this blue cable, it says console. I'll click on it and then we'll click on the router. Select the console port and then click on the PC. Select the RS232 port. Now let's connect the switch with the router. Select the copper straight through cable. Click on the router and select the first port, which is Gigabit Ethernet 0/0. Click on the switch and select the first fast Ethernet port available. We'll repeat the same for connecting the PC and the switch. Click on the copper straight through cable. Click on the switch. Select the first available port in the switch now and then click on the PC and select the fast Ethernet 0 port. Now that our workspace is set up and we have connected our PC to the router via console cable, let's see what happens when we access a brand new Cisco device. We'll explore the default user levels as we encounter before any passwords or security are configured. We'll cover what each mode means and how to secure them later. For now, just observe the out-of-box behavior of a Cisco IOS device. Click on the PC, go to the desktop tab and click on the terminal. I'll leave the terminal settings as default and click on OK. Let me drag the screen to the center a little bit. I'll click on the screen and press enter. We start in the user exec mode. This is the most basic mode. We can run some simple commands like show version to view device info, but we cannot change anything from here. Type enable to enter into privileged exec mode. Now we have access to the advanced diagnostic commands and we can start making changes. This mode is like having administrator rights. Type configure terminal to enter global configuration mode. Here you can change the router setting like its name, interfaces and more. This is the main mode for setup. Now let's configure the main LAN interface. We'll enter the interface config mode. Type interface Gigabit Ethernet 0/0. You are now in interface configuration mode. Here you can set options for this specific interface like its IP address, speed or shutdown state. Let's assign an IP address to this. I'll type IP address space 192.168.1.1 space 255.255.255.0. Now let me press enter and then I will type no shutdown. I'll drag my screen a little bit right to the router and you'll see as soon as I enter the no shutdown command, the router link will become green. Watch. Exit returns you to the global config mode. type exit again to return to the privileged exec mode. If you now type disable, you will be back to the user exec mode. Have you noticed that there were no points where we were asked for a password? We could move between the modes, configure the IP address without any restrictions. Anyone with console access or remote access, if an IP is set, can take the full control. So there are few key takeaways from that. Cisco routers are wide open by default. No passwords, no restrictions. You can do almost anything right away. This makes the initial setup easy, but it's risky. The next step must be securing the device before connecting it to any real network. So in the next step, we'll set up the host name, disable the DNS lookup delays, create a full privileged admin, secure enable with enable secret, prepare and force SSH-only remote access, and make the console pleasant to use. But before we do that, let me quickly reset the router. I'll click on the router and then we'll click on the zoom in button. We'll turn off the router. And now we'll turn it back on again. That's it. So let's now access the router via the console port using the PC. Click on the PC, go to the desktop tab and click on the terminal. I'll leave everything as default again and click on OK. Notice that when we connected to the router, there was no warning or login notice displayed. Ideally, we want a message to appear as the very first thing the user sees, such as a warning stating authorized personnel only. So let's set a message of the day banner. For that, first switch to the global configuration mode. And then we will type the command banner MOTD followed by the message authorized personnel only. Now let's exit the terminal . Notice the banner is now shown to all the users before access, meeting any legal or security requirements. Right now on my screen, notice the prompt is just router, which is generic. In a multi-router environment, this is confusing as you can't tell which device you are working on. So let's fix this. From the user exec, go to the privileged exec mode. And then switch to global configuration mode to set a unique host name. Type the command hostname followed by the host name which you want this router to have. Notice the prompt changes to R1 config. This instantly tells you which device you are configuring. Now every time you see the prompt, you know you are on router R1. This is critical for avoiding mistakes in large environment and configuring them remotely. Now let me show you the DNS lookup delay problem which you may encounter on a very frequent basis. Current mode is global config mode. We need to switch back to the privileged exec. Now let's make a typo in the command and watch what happens. The router tries to solve the typo as a host name using DNS, causing a frustrating delay. I'll fast forward this. And go back to the PC again. Now let's fix this problem. Let's switch to the global config mode and disable DNS lookup. Type the command no IP domain lookup. Now let's go back to the previous mode and let's repeat the typo. Notice that the error appears instantly and thus saving our time and avoiding confusion. Now let's start in the user exec mode and then try to enter the privileged exec mode. Notice that no password is required. Anyone can get full admin rights and this is a huge risk. Let's switch to the global config mode and set a secure encrypted password for privileged exec. Type the command configure terminal and then enable secret followed by the password. I'll use admin12345. I've kept it simple considering it's just a demo. Real-world passwords need to be more complex than that. Now let's exit the global config mode and exit to the user exec mode by typing disable. Now let's try to enter the privileged exec mode again. You will notice that now it is asking for a password. Let me enter the password. So you noticed now a password is required and only authorized user can access this admin mode. Now what if we want to set user accounts for accountability and auditability? For that, we first need to set local user accounts and password. I have used the word local signifying that they only exist inside this router. Let me first show you there exists no user on this router. I'll type the command show running -config followed by the pipe symbol and the exact phrase that I'm looking for. By the way, if you are wondering, this is just to filter the output. There is no output which tells us that no users exist. Anyone with console or remote access can try default credentials. There is no named account for accountability. So how to fix this? So let's create a local admin account with full rights and a strong password. Let's switch to the global config mode. Type configure terminal and then type the command username admin privilege 15 secret and the password. So this creates a user account named admin, assigns the highest privilege level, which is 15, that will give the full administrative rights to this user, and then sets the password for the account to admin456. The secret keyword ensures the password is stored in an encrypted format. Let me press enter. Now let's verify if the account is present. I'll switch back to the privileged exec mode. Now we'll run the previous command. I can use my up arrow key to go back to the previous command. I'll run the same command again and press enter. Now you see this command this time gives some output. This account that you see can be used for all console and remote sessions. This enables per user tracking and better security. So we have created the account, but is this enough? I would say no. Creating the user account alone does not enforce login. By default, console and the VTY lines may still allow access without requiring a username and password. To actually leverage this account for authentication, we need to do some additional configuration. So let me show you the current console line configuration. Type the command show running config, again followed by a pipe symbol, and type section line con. Notice that there is a single line output. That means that the console is open by default, no login required, and no session timeout is configured. This means anyone with physical access can immediately start configuring the device. And if you leave the console session open, it stays active indefinitely. This is a security risk and poor practice. Now we'll secure the console line by requiring authentication and setting an automatic logout for idle sessions. To fix this, let's go to the global config mode. Type configure terminal and then select the console line by using the command line console 0. This is where you set security and session options for users connecting via the console cable. Let's use the command login local. This will require users to log in with a local username and password that we have created earlier just now when accessing the console. This enforces authentication for console access. Now type the command exec timeout followed by 5 and 0. This sets the session timeout for the console line to 5 minutes and 0 seconds. If the console session is idle for 5 minutes, it will automatically log out, reducing the risk of unauthorized access if left unattended. Keep in mind that securing the console line is a critical first step in hardening your device. It prevents unauthorized access and enforces good security hygiene. So now let's see this in action. Let me exit all the modes and now observe the login prompt. It is asking me for a username and password. I'll type the username admin and the password that we have set. Notice that we directly reached into the privileged exec mode. Because the local account was created with privilege level 15, you are granted the full administrative rights immediately upon login. This means you land directly at the privileged exec rather than the limited user exec mode. Privilege level 15 users bypass the lower level access and have full configuration and diagnostic capabilities from the start. Moreover, if you now leave the session idle for 5 minutes, it automatically logs out. But I won't wait for that long, respecting your time. So to summarize, console access now enforces authentication and session timeout, improving security even in a lab environment. Now we need to assign an IP address to the router so that we can manage it remotely. Let's check the interface status first. Type the command show IP interface brief. As you can see, there is no IP configured to any of the interface. So let's switch to the interface config mode and assign an IP address and then bring up the interface. We need to switch to the global config mode first. Type the command interface gigabit ethernet 0/0 and then use the command IP address followed by the IP address. I'll be assigning 192.168.1.1 followed by the subnet mask 255.255.255.0. By default, interfaces are shut down and must be enabled. So use the command no shutdown to activate the interface. Now we can exit the interface configuration mode and return to the global config. Now let's check the interface status again. I need to exit this mode, and in the user exec mode, I should use the command again show IP interface brief. As you can see, an IP address is assigned to the interface gigabit ethernet 0/0 The router is now reachable on the network. Now it's time to configure the router for SSH setup. But before that, we need to configure our PC. In this setup, our PC is a fresh device with no configuration. We need to assign a static IP in the same subnet as that of the router. So let's do this. Go to the Config tab, select the Fast Ethernet 0 interface. Make sure that you have selected the static radio button and assign an IP address. I'll assign 192.168.1.15 with a subnet mask of 255.255.255.0. Now from the PC, try to SSH to the router. The connection should fail because SSH is not enabled, yet no domain name or RSA key has been set so far. So let's go to the desktop. Go to the command prompt and type the command ssh-l admin and the IP address for the router. We knew it would fail as SSH is not enabled on the router. Moreover, on the router we can verify the SSH status. Let's go to the terminal again and search show IP SSH. You'll see that SSH is disabled. So now let's set up the SSH. Before we do that, we need to set up the domain name and generate strong RSA keys. First, let's switch to the global config mode. Here, type the command IP domain name lab.local. This sets the router domain name to lab.local. This is required before generating RSA keys for SSH. Now, in the same mode, type the command crypto key generate RSA general keys modulus 2048. This command generates a general purpose RSA key pair with a 2048-bit modulus. It will be required for enabling SSH. You could use also the usage keys option instead to generate the separate keys for encryption and signature. But general keys is simpler and recommended for most SSH setup unless you need some advanced separation for PKI or certificate-based authentication. Now let's set up the SSH version to 2.0. Now let's check the SSH status again. We'll exit the config mode and here type show IP SSH. The SSH is now ready for secure remote access. Time for some theory. So SSH is a secure protocol for remote management. To enforce security, you must configure VTY lines to accept only SSH connections and restrict access to trusted IP ranges. Now you must be wondering what are VTY lines that I'm talking about and how do they matter. So VTY lines are virtual terminal lines on Cisco devices that allow remote CLI access over the network. When you connect via Telnet or SSH, you are using a VTY line. By default, these lines accept connections from anywhere and allow both Telnet and SSH. By default, anyone on any subnet can try to SSH or Telnet to the router. Let's check the VTY line config. Type the command show running config and filter the output. It isn't securely configured at the moment. If it was, the output should show more than this. Now let's secure the remote access setup step by step. First, let's create an ACL. An ACL is nothing but an access control list, which is a set of rules on a router or a switch that controls which devices can access or communicate within the network. It lets you permit or deny traffic based on IP addresses, making your network more secure. So let's jump to the global config mode. Here, type the command IP access list standard and give it a name. I'll give it management SSH. This starts a new standard ACL named management SSH. Now type the command permit 192.168.1.0 and 0.0.0.255. Keep in mind, the 0.0.0.255 is a wildcard mask, not a subnet mask. In Cisco ACLs, the wildcard mask specifies which bits of the IP address should be ignored during match. Here 0.0.0.255 means the last octet can vary, allowing all hosts in the 192.168.1.0/24 network. Now we can exit. Since now we have created an access control list, let's apply it. In this mode, type line VTY 0 space 4. This selects the VTY lines 0 through 4. Type login local. This will require users to authenticate with a local username and password. And here type the command transport input SSH, which will only allow SSH and disables telnet. Now let's apply the ACL as well. Access class and the name of the access list. The in that you see at the end means that the ACL is applied to incoming connections. Now let's set up the idle timeout as well. So it will disconnect the idle sessions after 10 minutes. By locking down the VTY lines, we ensure that only trusted users from approved networks access the device remotely, and only via secure SSH, not telnet. So now let's check the VTY configuration once again. I'll exit this mode, and in the privileged exec mode, we'll type the command show running config and we'll filter it for the VTY line config. Now we can see that only trusted subnets are allowed, SSH is enabled, and session also auto logouts. We are almost there. So far, whatever the changes we have done are not saved anywhere. They are part of the running config. Running configuration is the active configuration in RAM. All changes you make via CLI are applied here instantly. If you only change the running config and reboot, all your work is lost. You must save to startup config in NVRAM to make changes permanent. By the way, startup configuration is stored in NVRAM, which is non-volatile RAM. This is the config the device loads when it boots up. It persists across reboots. So let's check if a startup config exists. Type the command show startup config, and it says startup config is not present. So let's save our running config to NVRAM. Type copy running config to startup config. Destination file name, I'll keep it as default, and it's done. Now our changes will survive a reboot. The device loads the saved startup configuration from the NVRAM automatically. Now let's verify whether the SSH is now enabled or not. I'll go to the desktop and the command prompt, and we'll use the above command. Now as you can see, it is asking for a password. I'll enter the password and press enter. As you can see, now we have successfully authenticated and configured our router. We built a strong foundation for managing Cisco devices securely and efficiently. Things that we have learned today. how to confidently navigate Cisco IOS and its CLI modes, why securing devices from day zero is critical, step-by-step secure setup for routers, setting the hostname, banner, and enable secret, creating a local admin account, locking down console and VTY lines, enabling SSH, configuring ACLs, etc. With these skills, you can set up any Cisco device for secure, reliable management, whether in a lab or a real network. Always start with a secure baseline. Verify your work and save your configuration. This is the professional way to work, and it's the foundation for everything that we'll be doing in the future labs. Thanks for watching.